welcome to my YouTube channel, Chem Easy. And here are some sample questions you may likely see in your exam. So today I'll be solving some of those sample questions you may likely see. So we'll start with the first one. It says A is a solution of tetracyclic acid, then B is a solution containing 0.0340 mole per dm cube of sodium carbonate. As usual, put A in the bullet and titrate 20 cm cube or 25 cm cube portion of B using methyl orange as indicator. Record the size of a pipette, tabulate the readings, and calculate the average volume of acid. So from our previous video, our endpoint is we're using 21.44 cm cube as the average volume of acid used. Then from your results and data provided, calculate amount of sodium carbonate in 25 cm cube of B used, concentration of A in mole per dm cube, concentration of A in grams per dm cube, number of hydrogen ions in 1 dm cube of A, and mass of sodium ion formed in the solution during the titration. So we'll start with the first one, which is amount of sodium carbonate in 25 cm cube of B. Now when you want to do this, you use this simple formula, from your formula, which is concentration in mole per dm cube. Concentration is equal to amount. This is the formula for concentration. Amount in mole over volume of solution, volume in dm cube. Okay, so we want to calculate the amount of sodium carbonate, which is this one, amount of sodium carbonate. Now we've got to the concentration of NECO3 in the given to us in the question as 0.034. so our concentration is 0.0340 mole per dm cube, and the amount is what we're looking for. Amount is unknown, what we are looking for, and the volume, he said we should calculate the amount in 25 cm cube, which is the volume of the pipette used. Okay, so but take note, our volume here is in dm cube, so we'll convert the 25 cm cube to dm cube by dividing with 1000. All right, so if you divide with 1000, that is 25 divided by 1000, you have 0.025, which is 0.025 dm cube. All right, so now let's go for that to substitute. Concentration is 0.0340 mole per dm cube is equal to amount, we're looking for amount, over our volume, which is 0.025 dm cube. All right, dm cube, take note, dm cube, you cancel dm cube here, you cross multiply, you have amount equal to 0.0340 mole times 0.025. All right, so now let's do that quickly. So we have 0.0340 times 0.025. So we are having amount to be 0.00085 mole as our amount. All right, so we'll go back to the next question. Next one says we should calculate the concentration of A in mole per dm cube. Concentration of A in mole per dm cube. All right, so to calculate the concentration of A in mole per dm cube, we use this formula, CaVa over CbVb equal to Na over NB. All right, so our Ca, which is the concentration of the acid, is what we are looking for, is unknown. Our Va, which is the average title value, is 21.44 cm cube. Our Cb, concentration of the base, is given to us here as 0.0340 mole per dm cube. Vb is the volume of your base, which you get from your pipette. It will be 25 cm cube. Then Na and your Nb, you can get them from your balance equation. You know the reaction is between sulfuric acid plus sodium carbonate. So you have to get sodium sulfate, water, and carbon dioxide gas. So the mole ratio is 1:1. So Na is 1, Nb is also what, 1. So we'll go further to substitute this into our equation. So doing that, substituting into the equation, Ca is unknown times Va, which is 21.44 over Cb, which is 0.0340, take note, cm cube mole per dm cube, times Cb, which is 25 cm cube, equal to Na, which is 1, over Nb, which is 1. All right, so you can if you cross multiply, you have Ca times 21.44 equal to 0.0340 mole per dm cube times 25. So let's go and multiply these two together and see what we have. That is 0.0340 times 25. We have 0.85. Okay, so we have Ca times 21.44 equal to 0.85 mole per dm cube. So to get our Ca, we divide both sides with 21.44 over 21.44. So this go over to this. So Ca becomes 0.85 divided 21.44. So we're having 0.0396 mole per dm cube. So this is our the concentration of our acid. Okay, so our concentration here becomes 0.0396 mole per dm cube. Take note of that. So we'll go back to the next calculation there. It says we should calculate the concentration of A in grams per dm cube. All right, so we use this formula: concentration in grams per dm cube is equal to concentration in mole per dm cube times molar mass in grams per mole. All right, so concentration in grams per dm cube is what we are looking for. Concentration in grams per dm cube. The concentration in mole per dm cube would have it to be 0.0396 mole per dm cube, then times the molar mass of it. A is H2SO4. So you calculate the molar mass of H2SO4, which is by summing their individual masses. You have 2 times 1, you have 2 plus sulfur is 32, oxygen is 16 times 4 will give you 64. So you sum all together, which is 2 plus 32 plus 64, you have 98. Okay, so that is 98 grams per mole. So you multiply both together now. That is 98 times the 0.0396. You have it to be 0.0396 times 98. So you should have 3.8 grams, or approximately 3.9 grams per dm cube as the concentration in grams per dm cube. Okay, so we'll go back to the fourth one here. Number of hydrogen ions in 1 dm cube. Number of hydrogen ions in 1 dm cube of the solution. So this is how you do it. Very simple. First, you take note of that our A, which is H2SO4, the concentration is 0.0396 mole per dm cube. Alright, so to calculate the number of hydrogen ions, H2SO4, which is our acid, ionizes as follows or dissociates to give us hydrogen ion and sulfate anion. Alright, we have 2 moles of hydrogen ions to balance the equation. So from the equation here, we want to calculate the number of hydrogen ion, which is this one, in 1 dm cube of the solution. Okay, now from the stoichiometry of the reaction, we know that 1 mole of sulfuric acid will ionize to give you 2 moles of hydrogen ion. And then take note from the our question here, take the concentration of the acid is 0.0396 mole per dm cube. So now 0.0396 mole, which you have in 1 dm cube, will give us how many moles of hydrogen? We cross multiply. So when you cross multiply, this times this gives you what? That is 0.0396 times 2, 0.0792. So we have S to be 0.0792 moles of hydrogen ion. So this is the number of moles of hydrogen ion we have in 1 dm cube, the number of moles. So, but take note, we were asked to calculate the number of hydrogen ion. This is in mole. So for you to calculate the number of hydrogen ion from the Avogadro's constant we are given there, 1 mole of a substance contains 6.022 times 10 raised to the power 23 what ions or particles. Okay, then if 1 mole contains it, then this number of mole will contain how many, which is 0.0792 moles of hydrogen. Okay, will contain how many ions in 1 dm cube? As usual, we cross multiply. That is 1 times S gives us S, then 0.0792 times the Avogadro's number gives you have 4.769 times 10 raised to the power 22 hydrogen ions. Go back to the last question here, which says we calculate the mass of sodium ion formed during the wort titration. Alright, but take note, don't forget our concentration of the sodium carbonate, which is Na2CO3, from what we are given is if you check 0.0340 mole per dm cube. Alright, and sodium carbonate in water ionizes as follows to give you sodium ion plus carbonate. Alright, take note, here is 2 sodium, so we'll balance here to make it 2. So from the mole or from the stoichiometry of the reaction, 1 mole of sodium carbonate we ionize to produce 2 moles of sodium ion. So the question we're asked now is to calculate the mass of this from doing the titration. And I think during the titration, this is the concentration of sodium carbonate, and the volume of it we use for the titration is 25 cm cube of sodium carbonate with this concentration. Okay, so now let's convert 25 cm cube of 0.0340 mole per dm cube to mole, because take note we are using mole relationship here, okay, which is amount. To do that, we have concentration is equal to amount in mole over volume in dm cube. Okay, now the concentration we have it to be 0.0340 equal to the amount, which is what we are looking for, amount over the volume is 25. Convert to dm cube, we have 0.025. So when you multiply everything together, 0.0340 times this, you should be having let's do it, that's 0.0340 times 0.025, 0.00085. So amount is 0.00085 mole. Alright, take note. So here we have 0.00085. Now if 1 mole of sodium carbonate produces 2 moles of sodium ion, then in the reaction 0.0085 mole will produce how many? Yes, we cross multiply. When you cross multiply, that is you're multiplying it with 2 now, so we have 0.0085 times 2, so we have it as 0.0017 mole of Na plus. So this is the number of moles of sodium ion that is formed in the titration. But take note, we are asked to calculate the mass, so all you have to do is to convert this mole to mass. Now for you to convert the mole to mass, you use this relationship here, which is mole equal to mass over molar mass. Alright, the mole we've gotten it to be 0.0017. we are looking for the mass, and the molar mass of sodium is 23. So we cross multiply, mass is equal to 0.0017 times 25. Alright, so we have 0.0017 times 25, sorry, times 23. Take note, sorry, mass of 1 sodium is 23 times 23, so 0.0017 times 23, we have to be 0.0391. 0.0391 grams. So this is the mass of sodium produced during the titration. This sample question 2 you may likely see. It says A is 0.0396 mole per dm cube of H2SO4. Then B contains 1.8 grams of sodium carbonate in 500 cm cube. As usual, put A in the burette and titrate with 20 cm cube or 25 cm cube portion of B using methyl orange as the indicator. Record the size of a burette, pipette, and tabulate the readings. Then from your result and data provided, calculate concentration of B in mole per dm cube, concentration of B in grams per dm cube, amount of sodium carbonate in 25 cm cube of B used, and volume of carbon dioxide produced from 25 cm cube of B at STP. So we'll start with the first one. Now take note, the equation for the reaction is between hydrogen, sulfuric acid plus sodium carbonate. Alright, when an acid reacts with a carbonate, it gives you the corresponding sort of the carbonate plus water, and then carbon dioxide gas, which is given off. Okay, so now let's have the first one, which is the concentration of B in mole per dm cube. To calculate the concentration of B in mole per dm cube, we are given that B contains 1.8 grams. So we have 1.8 grams of sodium carbonate in 500 ml of solution. So if we dissolve 1.8 grams of sodium carbonate in 500 ml, what is the concentration of the reaction? You can use this formula to get that, which is a concentration given in grams per dm cube is equal to mass in grams over molar mass in grams per mole times 1000 over volume dm cube. So let's do this and have the answer. Concentration, the mass is 1.8 grams, molar mass of sodium carbonate is 106 grams per mole times 1000, and the volume is 500. All right, 500 on dm cube, 500. So once you multiply these together, you have 0.0340 mole per dm cube. So this is the concentration of B in mole per dm cube. So we'll go back to the next one, which says we should calculate the concentration of B in grams per dm cube. Concentration in mole per dm cube, we've gotten it to be 0.0340 mole per dm cube. So now to calculate concentration of B in grams per dm cube, we have concentration in grams per dm cube is equal to concentration in mole per dm cube times molar mass in grams per mole. All right, so our concentration in mole per dm cube, we got it to be 0.0340 mole per dm cube times the molar mass. Our molar mass of sodium carbonate is 106 grams per mole. All right, so when you multiply both together, let's do it so that we'll get the answer. That is 0.0340 times 106. We have 3.6, approximately 3.6 grams per dm cube. So concentration in grams per dm cube is equal to 3.6 grams per dm cube. That is our concentration in grams per dm cube. All right, so we'll go over to the next one, which says calculate the amount of sodium carbonate in 25 cm cube of B measured. All right, very simple. Concentration is equal to amount. This is the formula for concentration: amount in mole over volume in dm cube. So now I want to calculate the amount of sodium carbonate. We've already gotten the concentration to be 0.034. So we substitute. Take note, concentration is 0.034 mole per dm cube. Amount is what we are looking for. Amount is unknown. Then the volume, we said in 25 cm cube. 25 cm cube. You convert 25 cm cube to dm cube. Take note, because our unit here is in dm cube. That is, you do that by dividing with 1000 to have 0.025 dm cube. So substitute, make amount subject of formula by cross multiplying, and then substitute into the equation. So we have amount is equal to concentration in mole per dm cube times volume in dm cube. All right, so let's go. Amount Our concentration is 0.0340 mole per dm cube times volume, which is 0.025 dm cube. Making dm cube cancels dm cube. Then let's multiply this and have our answer, which is 0.0340 times 0.025. So we're having 0.00085 mole. So that's the amount. So now let's go over to the last one, which says we should calculate the volume of CO2 produced. Calculate the volume of CO2 produced. That is from the reaction, H2S24 react with sodium carbonate to give us sodium sulfate, water, and CO2. So we are then asked to calculate the volume of CO2 produced from 25 cm3, that is or P of the reaction, the volume of CO2 gas that is being produced. Alright, so we can do that by using this simple relationship. From the reaction, you know that 1 mole of sodium carbonate is producing a gas. 1 mole of it is producing 1 mole of CO2, and 1 mole of a gas occupies 22.4 dm cube. Alright, so 1 mole of this is producing 22.4 dm cube of CO2 gas. Alright, then from the reaction, the 25 cm cube, we use 25 cm cube of 0.0340. This is the concentration of the B, and this is the volume we use for our pipette. Alright, so if you convert this to mole, because here we are using mole volume relationship, if you convert this to mole, this is what we have, which is what we did in this amount, which is mole of sodium carbonate with 5. We got it to be 0.00085. So if 1 mole is producing 22.4 dm cube, 0.00085 mole will produce what volume of CO2? We cross multiply 1 times S gives you S, then this times 22.4. Let's do that. 0.0085 times 22.4. So we have 0.0190. 0.0190, a 3 significant figure, dm cube of carbon dioxide is produced. Okay, all right.